2 ladies and a lot more gentlemen. Welcome back to the last session of this day. I see a lot of, let's say, tiring faces, but no worries. Only 1.5 hours, and then we'll go to the restaurant, in Heidegger especially. And in this remaining time, I want to introduce the OPALS software from a practical point of view. Not me alone, but Lothar will assist me. I will hand over. I will do the first part, and Lothar will then continue. I want to cordially thank you, Pete, for introducing the command line, because I'm pretty sure that now nobody fears the command line any longer, and we will do a couple of, let's say, commands on the command line as well. As I pointed out in the morning, that the OPALS is, let's say, a processing-oriented software. So let's just jump right in the middle of the subject. You find a screen which should be similar to the one which you see here on the beamer, and the things which you need would first be the UFAR shell, and by double clicking you get a command window with a menu. So keep this ready. Maybe a bit smaller. And the second thing is you find a shortcut to the data. Just double click it, and Windows Explorer opens right in the folder where the data are. Additionally, we have provided a presentation for whatever we're going to present now. This is under day 1, so in a parallel directory to data with presentation material. You may or may not, it's up to you, have this presentation ready. Anyway, it is not let's say necessary to have it open, but probably you will find it convenient to have this material ready for you. So it is if you go to the Windows Explorer and it starts in data, and you find it in a parallel directory to data. It's just day 1 presentation material. And there is only one file in here. Just 3 names, which is my name, Lothar's name, and the name of the software, and intro, and that's basically it. Okay, so let's first go back to the data directory. And first thing we want to do is before even entering OPALS, we just want to introduce the data set to you. We saw it on the slides from my presentation from in the morning. It's the Schönbrunn data set, but just to give you an impression about the point that we are dealing with, go back to your menu, to your UFAR shell, and the second option is Fugro Viewer. So type 2 and enter to select the Fugro Viewer and to start up the Fugro Viewer. And then either use file open, or I just drag and drop the file which is in data. The file is called SB for Schönbrunn -large for a large version of the dataset.las. So it's again a LAS file as Pete used it in his presentation, and just drag it in here. And then a screen similar to that should open up, showing you, in this case, a color-coded version of the point cloud in terrain colors, with green being the lower elevations and, let's say, white or grayish tones the higher elevations. How do we know that? Simply click to 3D, and then on the right hand side, a 3D window opens, and you can use the scroll, the mouse wheel, to zoom in and zoom out. And you can use the right mouse button to do a panning, right mouse button, scroll in, scroll out, and probably you want to concentrate on this building in the let's say right hand part of the ground plan in this case, which is the castle, the Schönbrunn castle. You can even do a zoom in the plan view by left clicking a window like that, which will then zoom in here in this respective area, and you can see here the quite complex roof of the Baroque castle, as you see here. You can turn it around. This is the courtyard in front of the castle. You zoom out again here. What we else see here is the Baroque garden in here with some regular pathways, as you can see, and some lower vegetation. So this is a planted field, as you see, with bushes and smaller trees. And in the middle, you have a large meadow in here, as you can nicely see in the point cloud. And on the left-hand side of the ground plan, actually it is not the western, it is really the left-hand because it's a bit rotated, the data set in here. You find the two water surfaces here, two ponds, and in the middle of the pond you find the summer, it should be the summer palace called Gloriette, actually, for those of you who are interested in this one. Is it here? Where is the Gloriette?
Not in between.
Yep. Yeah, here it is. Right at the end of the data set you find the summer garden. And you find here in the let's say higher ground area even higher trees, so it's really forest type vegetation here. So we have quite a mixture of land cover, low vegetation, higher vegetation, gardens, shrubs, bushes, houses, everything, water surfaces. Okay? So if we're done with that, then we can close it and we can, let's say, try to do something with this data in OPALS. And to do this, go back to your workshop shell and select 4, which is the menu item for the OPALS shell. First difficulty, we need to change into the data directory. So the data directory can be found here in the Windows Explorer. Just click on the line here and copy your path. I do it always with Ctrl+C, but you have your own technique, I think. And then just type cd/d, and the right click on the mouse introduces the address. In this case, pardon? Ah, yeah, it was not a /. Where is the / on my keyboard? Yes, like that. So that everyone should then be in the day 1 data folder. And if you were successful in doing so, and you write you submit the dir command on all the last files, then we should find 3 data sets in here, one of which is the sb large.last file, which we just viewed in the Drupal view. I'll just give you a few seconds. It's fine with all of you?
Only one last file.
There's only one last file, but it's important.
Okay.
We will deal with that. Great. You're done? You're all done? First row is done. Second row? Third row? Fine with you? Yes? Okay. So the first thing which we have to do is to import the data into the OPALS data manager structure. What Pete told us with importing the data into the SPT format is a similar step in OPALS by importing the data into the ODM, as we call it. And the command for this is OPALS import. So just type OPALS import, and if you don't know the parameters, then just click enter, and you get a usage screen with a couple of parameters. And I don't want to annoy you with all the parameters, so simply write. I think we can also omit the OPALS in front, so just write import minus in file. You can abbreviate it also, so I only write inf, and then the name of my LAS file, which in this case is sp-large.las. And press enter. And doing so, the LAS file gets imported into the ODM structure. How do we know that it was successfully imported? Have a look at the Windows Explorer, order your files by date, and you should have in the topmost, one of the topmost, a file called sp-large.odm. So we didn't supply an output file name, so it was estimated. This was just one of the things which I told you in the morning. There are different kinds of parameters, some of which we have to specify, in this case the import file, some of which we don't have to specify because they can be estimated by the program. In this case, this was the output format, output file, sorry, which is an ODM file. So what you might be interested, what is in this file? If the ODM would be in HDF5 format, we would run an HDF5 viewer. In this case, we have a separate module called info. So just type info minus in file. I always abbreviate it with inf, and then the name of the ODM file. In this case, it is sp.odm. Info minus inf sp-large.odm. I know what I have to do. I have to do like that so that you can see it. Should we enlarge the font, or is it fine with you in the last row? The size of the font is fine? Yes? And if we submit it, then we get a list, an overview about the contents of the file. File name, point count, in this case it is 1.5 million points, no lines, no polygons, extents in X, Y, and Z, and a list of all the attributes. So I told you that part of the ODM is the, let's say, spatial structuring of the data, spatial indexing of the data, but the second side of the story is the attribute scheme. It's a flexible attribute scheme. And in this case, all the attributes which are stored in the LAS files have automatically been, let's say, transported into the ODM. As you can see here, we have the echo numbers ranging from 1 to 5. We have classifications, but no classifications are specified in this case. What else do we have? Well, nothing worth mentioning, I think, in this case, right? But we do have, as you see, amplitude values. Yes, we have amplitude values ranging from minimum 0 to 350 with a mean value of so-and-so and a sigma, a standard deviation of so-and-so. So for each and every attribute in the header of the ODM, we store additional standard statistical values of the attributes. Okay? So our goal would probably be to really straightforward interpolate the model and visualize the model, right? So to do this, we would, as Pete did it, run a gridding, and the gridder in OPALS is called OPALS grid, or simply grid here on the command line. We specify the name of the ODM as input, so again in file sp-large.odm, and we would have to specify at least one additional parameter, which is the interpolation method. We heard from Pete, he has natural neighbors, tin, and things like that. We tend, but we have also a couple of interpolators, one of which we are quite often working on is the moving planes interpolator. So simply write inter as an abbreviation of interpolation, and then moving planes. PL is sufficient. Moving PL, and we'll let the program do the rest of the parameter estimation. So what you see now is that this is an statistics of our input file format. We use this from the info as well, already. Then we had the info for the generation of the grid, which was actually carried out with 4 grids, with four threads. So apparently my machine has four cores. I don't know how it is on your case. Probably it was only 2. So if you don't specify it explicitly, the program uses as many cores as there are available on your machines. So as I pointed out in the morning, as long as we also do tiling as Pete does it with his data, but additionally we try to parallelize the processing on the basis of one ODM file, which is done in this case. Yeah. So this is the basic story behind this. We have this coarse regular structure with this 2-level index, spatial indexing, as I pointed out in the morning. So first the regular structure with the coarse tiles, and then the KD tree as the really, let's say, spatial indexing of these individual points. But on this basis, we're able, let's say, to distribute the processing onto the different cores which we have on our computer. But this is all done internally, right? But I completely agree with Pete. This makes sense up to a certain, let's say, level of parallelization. But you will soon see that the I/O is then the bottleneck, and then it would definitely make split it up into more processes. Yeah. So probably it's a hybrid structure which we, let's say, run in this case. Okay, so what did we produce now? Having a look again at the file folder shows you that we have produced a file called sb-large set.tif. So actually, TIFF, you already know what TIFF is. It's a raster file format. So we produced a raster out of the point cloud. And the attribute which we used was actually the set, the elevation. We didn't specify it explicitly. And we would have had the chance to use any other attributes. So we would have been able to grid the attribute, the intensity values, the amplitude values, simply by specifying OPALS grid minus attribute, whatever name of the attribute you want to be gridded. If you don't specify it, then the default is the set, right? So basically this gives us a DEM. This is a grid, DEM grid model. And in order to visualize it, we probably run the QGIS GIS, which can be found under the option 5 in your menu. So this starts QGIS 2.4. I go back to my Windows Explorer and just do a drag and drop of this file into the panel here. It asks me for a coordinate system. Just use whatever you want to have. And what you find here is basically a set coloring. No, well, it is a gray tone representation of your DEM model, showing the lower tones in black and the higher ground in white. Okay, so far so good. Probably this gives me the opportunity, the second file in here. You see there is a log file. I told you a bit about this framework which is dealing with not only but also with the logging, right? So whatever we process, whatever we do, and whatever on log message we produce is stored in an XML file, so it should work just to double click it. And it hopefully comes up in an Explorer, as it does in my case here. Nope. And here you find, just in the header, we have 37 records from 3 runs. So actually we really run 3 programs. The first was the import, the second the info, and the third one was the grid. So everything which we did is documented. So Pete told us it's good practice to put all your commands in a shell script, so that you have it ready, and we highly support it. It's actually completely the same structure which we are, or the same practice which we are following.